Welcome to network broadcast and host addresses. So there are three kinds of IPv4 addresses in a network range. The first one we have is network address, then we have broadcast address, and finally we have host address. So an IPv4 network range is a group or range of IPv4 addresses that can be assigned to network devices within a logical environment to enable them to communicate with each other. Devices in different network ranges or subnetworks cannot communicate with each other except a layer 3 device, for example, a router, is used to interlink the subnetworks. So what this means is that IP devices can connect together if they are in the same IP network range or subnetwork. But when they are found in different subnetworks or different ranges, they require a layer 3 device to connect to each other. So IPv4 address ranges or subnetworks are defined by the subnet mask. The process of creating IP network ranges or subnetworks using the subnet mask is called subnetting. So let's look at what the network address is. And the network address is an identifier for a group of network devices with IPv4 addresses assigned to them. The network address is usually the first IP address in a network range or subnetwork. The network address has all zeros in the host portion of the binary octet equivalent of the IPv4 address. So this is very important to note that in the binary octet state, the network address has all zeros in the host portion. So let's look at this table and we can see that we've been given an IPv4 address as 203.113.2/24 subnet mask notation. And what that means is that the first three octets are all 255. That means they are the network portions of the IP address. So if we go down, we can see the subnet range. Because we've been given the first three octets as the network portions, it means that they remain static, while the host portions are the ones that we make up to form the IP subnet range. And in this case, we have from 0 to 255. So we can say that we have about 256 IP addresses we can get from this range. So the first IP address we can see is 203.0.113.0, and because of the definition we gave up here, we said the network address is usually the first IP address in a network range or subnetwork, and that's why, because 0 is the first IP address, usually is the network address. But we also stated that the network address has all zeros in the host portion. So let's see how that plays out. And if we can see this example we have of the same IP address 203.0.113.0, and we can see that the subnet mask has been given and the network portion has the all ones and the host portion has the all zeros. And we can see from here that the host portion is in binary form, is in all zeros. So this defines this IP address as a network address for that IP address range. So let's see the broadcast address. So a broadcast address is the identifier for all devices on a network with IPv4 addresses assigned to them. The broadcast address is usually the last IP address in a network range or subnetwork. The broadcast address has all ones in the host portion of the binary octet equivalent of the IPv4 address. So let's take note of that. It's very, very important because there is a big difference between a network address and a broadcast address. So basically, a network address identifies the network where all the devices are located within. And the broadcast address you can use to forward packets or messages to all devices within that network at once. So the network address more like defines the network, and the broadcast is more like defines the functionality of sending messages at once to all devices on that network. You can see from the same table that the last IP address, which is 203.0.113.255, is the broadcast address. Why? Because it's the last IP address in that network range. So let's confirm that. So we can see the same IP address, and we can see that the subnet mask, which defines the network and the host portion, has separated the network portion from the host, and it defines the host portion here as having all ones, as we can see up here. So that's why we have 255, which is all ones in binary form. So this clearly shows that this is a broadcast address. And finally, we have a host address. So a host address identifies individual unique devices on a network with IP version 4 addresses assigned to them. The host address is usually every other IP address besides the network and the broadcast addresses in a network range or subnetwork. Only the host addresses can be assigned to network devices. So this is very important, because you can't assign a network address or a broadcast address to network devices. Only host addresses can be assigned to network devices. So in the same table, we can see that we have the first IP address, which has been assigned as the network address. Then we also have a second IP address, which is 203.0.113.1, which is the first available host address. And we can see the second last IP address is 203.0.113.254, which is the last available host address. So from this, we can deduce that we have 224 addresses that are available to be assigned to network devices, while we have the singular network address, and we also have one broadcast address for this IP address range. So we can see from this example, from the IP address, that is neither all zeros nor all ones. If it were all zeros, we would have said it's a network address, but if it was all ones, we would have said it's a broadcast address. But in this case, it's neither of both, so we can easily identify this as a host address. So can you find out if these are network, broadcast, or host addresses? So let's pause the video and try our hands and see if we can solve this. So let's try the first one. It says 192.168.10.25/24. So this shows that it's a classful address, and it's a class C address because it's 192 and 24. And we can see from the subnet masks too. So from this, we can easily deduce that the first three octets, which are all ones, are the network bits. So we have 192.168.10, which will remain static because they are the network bits. If we keep this static, we should have 192.168.10.0 to 192.168.10.255. We should be able to get 255 IP addresses from this range, of which the network address will be .0, the broadcast address will be .255, and the IP addresses will range from .1 down to .254. And in this case, we have .25, so this definitely should be a host IP address. And that's what we have here, and we can see that the subnet mask identifies the fourth octet as the host portion, and we can see that it's neither all ones, which would have been broadcast, or all zeros, which would have made it a network. So this is definitely a host address ready to be issued to a network device. So let's try the second one. It says 192.168.10.255./24. So it's the same thing similar to the first one. This is also a classful address, class C. Of course, we have 192, which falls in the range of class C, classful address, and we also have 24, which is a confirmation of that. So we have that the first three octets, the same thing, are network portions. So that's what we'll have, and the same range we'll have is .0 to .255, and in this case we have .255. So this should be a broadcast address, and let's confirm that. We can see the solution for that, and we can see that the host portion, which is identified here, has all ones in the host bits. So that shows that this is a broadcast address. We also have the third one, which is 10.10.0.0/16, and we can see that this looks like a classful address, but this is actually a classless address, because remember, 10 for the first octet, it falls into the range of 0 to 128, which is class A. And we also know that class A should have a subnet mask notation of /8, but this time we have /16, which includes the second octet's 8 bits. So this has been adjusted, and it means that this is a classless way of addressing the IP address. So to solve this is the same thing. We can see that the first 16 bits are all network bits, and they remain static, and it means that the remaining 16 bits are the host bits. So we definitely know it to start this way with .0.1, then .0.2, .0.3. It will keep going to .1.0, .1.1, .1.2, then it will keep going to .2.0, .2.1 till it gets to .255.255. So clearly we can see that it being .0.0 is clearly a network address, because that is, or the first IP we can get from this IP range. So let's see if that's actually true. And here we can see that it's a network address, because if you come down, when you convert it to binary, you can see that the subnet mask converted to binary gives all zeros in the last two octets, and that identifies the host portion, which is the last two octets. And in the IP address, you can see that when converted to binary, the last two portions are all zeros, which indicates a network address. So that's why this is a network address. So let's try the last one. It says 10.128.224.64/27. So clearly we can see that this is a classless addressing, and we notice that it has a subnet notation of /27, which means that the first three octets, which is 888 bits, which makes 24 bits, are all network portions. And the last one, if you remove 24 from 27, we'll have 3 bits extra. So it means that from the fourth octet, we have 3 bits that are network bits. So it means we should have, because each octet is 8, we should have 3 bits for network, and we should have the remaining 5 bits for host portion. So there are 2 ways, or let me say there are 3 ways to solve this. The first way is the normal way of converting both subnet mask and the IP address to binary, and then we'll now identify the host portion and see if the host portion has all ones or all zeros, or there is a mixture of ones and zeros. 2 other methods besides that, which is like a shortcut method. Basically what I do is, the first method is I consider that since we have 3 network bits here in this portion, it means that we should use the formula we usually use, that's 2 raised to power 3, which will give us 8 networks. So, and what that means is that if we have 8 networks, 256 divided by 8, which should give us 32. So it means that each network has a step of 32. So it means that the first network we should have from this should be dot 0, then the next one will be dot 32, then the next one will be dot 64, then it keeps going that way. So that means that this should be a network address. Don't worry if you don't understand that method. When we're doing subnetting, I will show you how to do it. So the second method we usually use is when we consider 256, which is the limit point, and we subtract this from 256. When you subtract this, you get 32. So what that means is that easily I can identify this as a network. Don't worry if you don't understand that, I'll still explain it during subnetting. Let's look at the normal method we use, and when you come down, you see we actually have to convert this to binary, and if you convert the subnet mask, you can see that it identifies the host portion where it has all zeros, and if you come up to, when you've converted this to binary, the IP address, if you come up, you will see that the host portion is all zeros. So this identifies this as a network address. So basically that is how we classify network, broadcast, and host addresses from an IEP version 4 range.